For section 3, we're going to keep building on what we were just doing, but it's now with multiplying and dividing rationals. The trick is, when you multiply fractions, multiplying fractions is actually super easy. Remember that when you multiply fractions, you do top times top over bottom times bottom. But remember that when what we were just doing, we were factoring it, we had all these pieces multiplied together. So it's actually very much what we were just doing. For number 1, literally, you can just put this one in parentheses and make this one giant fraction. And it's exactly what we're doing before. We're looking for those identical twins, the things that are exactly the same that we can cancel out. Do you guys see any terms, factors, that appear on the top and the bottom? What do we see that we can cancel out, that we can reduce? Okay, again, with the math is hard to hear. A little louder. So n plus 4. Do we all agree? We can reduce an n plus 4 here and here, and that becomes just 1, right? That right there, n plus 4 over n plus 4 is 1. That's reduced. Anything else that shows up on the top and the bottom? The 5 and the n, right? Those are not added or subtracted anything. They will reduce also. So the 5s reduce, the n's reduce. All of that's just 1 times 1 times 1. And all we're left with is n minus 3 over n minus 4. And I cancel out the n's. No. Does that make sense? I'm going to keep asking you guys. I'm going to keep checking with you. We cannot cancel these n's out. I can say this 100 times in my Math 3 classes, and I still have students that reduce those. We cannot reduce n over n if they're both attached to a plus or minus. So that is my final answer. The next one, when it's multiplication, just make it one big fraction. Top of the first one times top of the second one. You can put it in parentheses if you want to there. Bottom of the first one times bottom of the second one. That one needs to be in parentheses because of the minus sign. That's all one piece. So let's see here. Let's get some names. I'm looking for identical twins that we can reduce. Caitlin, do you see one that we can reduce?
The 5 n's.
5 n's. So, and 5 n squared, right? That's exactly right. That's perfect, Caitlin. So now, anything else? Paramjot, do you see any other identical twins that we can reduce? Sorry, a little louder. The n minus 9 is correct. N minus 9. Here and here. Does that make sense to everybody? So what are we left with then? Isaiah, what's left on the top of the fraction? N plus 10. And again, if you want to, leave it in parentheses. That's fine. You don't need to, but you can. And then on the bottom, Amato, what's left on the bottom of the fraction? N minus 6. There we go. Does that make sense to everybody? And we're done. That one's finished. That's all we're doing. It's really the same thing as what we were doing before. With multiplication, it just means we have the top of the first one times the top of the second one. So it's just one big fraction, one with a one big top, one big bottom. The trick is we are going to have to factor in a little bit. So that's what we were just doing before. Right now, they've done a lot of the factoring for us, and so it makes it pretty easy.
Is that the answer?
Yep, that was the answer. N plus 10 over n minus 6. Number 3. They've already factored it for us. So we're just looking for, again, any big ones, any identical twins that show up on the top and the bottom. So let's see. Ayana, do you see anything on the top and the bottom here that we can reduce? A little louder. So we can't do the 3 by itself, but the v minus 3. Does that make sense? Is that what you're looking at? So the whole piece here, v minus 3, v minus 3, those are going to reduce.
What about the v negative 8?
Right, those are so close to being the same, aren't they? V minus 8, 8 minus v. There is a way to do it. We talked about this before. 8 minus v. I can factor a negative out of that. So if I want to make this look exactly like that, where the only difference is that they're switched in order and their signs are switched, I can make this 8 minus v into a v minus 8 if I factor a negative out of it. Because negative times v would be the negative v. Negative times negative 8 would be the positive 8. So it does work, but you have to take that negative out first. So now, those reduce. We're left with 2v squared over negative 5 plus v. That's not a v. 5 plus v. If you want to distribute the negative in and make it negative v minus 5, that's fine also. All right, so how about number 4? Working our way through here. So Olivia, do you see anything that these two have in common? Now we're back. Okay, actually pause. At this point, we're back to having to factor. They haven't factored this one for us, but it's the same thing that we were just doing. So Olivia, do you see anything that these two have in common? And one thing you can always check is, does 7 go into 70? Yes. How many times? Like, or what's, if you do 70 divided by 7, what's left over? 10. So we take that 7 out, and we're left with x minus 10. Now let's look at the bottom and get somebody else. 7x plus 28. Jada, can I reduce, or can I factor out 7 and 28? How many times does 7 go into 28? Yes. So we got 7 times x plus 4. Now this 1 doesn't do a whole lot. You can still put it there. 1 times 7 times x minus 10. So all the top pieces multiplied together. On the bottom, all the bottom pieces multiplied together. 7 times x plus 4 times another 7. You can either leave it back here or you could put it in the front. So now, what can I cancel out? I said it again. I'm going to have to break myself of that habit. What can I reduce?
The 2 sevens on the bottom.
So like this one and this one?
Yeah.
So have we, up until this point, have we canceled out stuff that's on the same side of the fraction? No, it's always like something on the top and something on the bottom. Okay, so I can cancel out, again, I can reduce 7 over 7 right here. Can I get rid of, can I reduce this 7 also? Now it's got to be 1 from the top and 1 from the bottom. And so if I'm reducing these, that one's gone. There's not a 7 on the top anymore. And that means this one doesn't have anything to reduce with it. Does that make sense? It's going to stay 1 over 7. So final answer for this one, you can have the 1 or not. X minus 10. I'd put the 7 out in front because that's how we normally write these. Number first, then factors that are in parentheses. X plus 4. That would be my final answer for that one. Let's look at number 5 now. This x plus 4 doesn't, there's nothing I can do with that, doesn't factor. X minus 2, same thing, but this guy, x squared minus 6x minus 40. I bet that one factors. Jeremiah, what are some ways to multiply to make 40? 8 times 5. So we've got 8 and 5. But unfortunately, 8 and 5 doesn't add or subtract to 6. So let's try another one. Roman's not here. Belandra, do you know another way to multiply to make 40? No? 4 times 10. 4 times 10 is a good one. 2 times 20, right? We have a bunch of different ways that we could make this work. But the one we want is actually the 4 times 10. Why is 4 times 10 going to work best for us? Because it subtracts to 6. 10 minus 4 is 6. So I'm going to factor that. X and 4, X and 10. What signs am I putting in there to make sure it matches exactly? Brandon, what do you think? How am I going to make this multiply to negative 40 but add up to negative 6?
Positive and negative.
So positive 4? All right. Do we all agree with that? We good? I think so. 4 times negative 10 makes negative 40. 4x minus 10x makes negative 6x. All over. You have that x plus 4 and the x minus 2. Christian, do you see any identical twins here that we can reduce? A little louder. The 4. So again, and when I'm talking about that, do use the whole piece. So the x plus 4. Does that make sense? So the x plus 4 over x plus 4 reduces to 1. That's just one big 1. And then here we've got x minus 10 over x minus 2. And do the x's reduce? No. They're both parts of subtraction. That is my answer. Doing well so far. Let's do a few more here. Number 6. Anakin, do you see anything that we can factor on number 6? What about the 72? Yeah, 8 goes into 72 how many times? 9, perfect. So we're going to take that 8 out. B plus 9. Put the b plus 5 in parentheses. And again, b minus 5. When we're multiplying fractions, it's just top of one times the top of the other. And then here, b plus 9 times 8. All right. Haley, do you see anything that reduces? Yep, b plus 9 up here, b plus 9 up here. All of that becomes one big 1.
That's a big one.
Yep. I was talking with some of the Math 1 teachers. I'm not even sure, but does the Math 1 stuff, if you think like 2 years ago, does it even like turn it into a giant 1 when they cross it off? Maybe, some of them. Maybe not. But the idea is that b plus 9 over b plus 9 is just one big 1. 1 times 8 times b minus 5, leaving us with just 8 times b minus 5. And on the bottom, am I done? I see yeses and I see nos. Which is it? So those of you who are saying no, what can I still do? Everybody see the 8s on the top and the bottom? They're not a part of pluses or minuses, right? They're multiplied in. It's 8 times b minus 5. So those 8s, 8 divided by 8 is 1. It does reduce. So our final answer there, b minus 5. All right, and we've been working at this for not quite an hour, for 50 minutes or so. So we're actually going to take a little break. We're going to finish this either today or Friday, depending. But I want you guys to get some hand sanitizer and grab a laptop, and we're going to do a little activity.